Welcome class to our next video, and we're going to get into something a little different here. We're going to actually graph some lines, and we're going to introduce the y-intercept this time. So we talked a bunch about slope, just the basics of what slope is, how to find it given lots of situations, and we'll talk more about slope today because you can't graph a line without slope. But what you also need is a y-intercept if we're going to graph it the way we're going to do today. And if you notice, there's this orange arrow pointing to this red dot, which does shrink and grow, and actually you can make it grow. Well, I guess I thought it could get bigger even, but that's okay. So it's pulsating to emphasize where that y-intercept is. And it makes sense that it's called the y-intercept because it's on the y-axis. So it's where a line crosses through the y-axis. And I have this little blue revealer, kind of like on the back of a cereal box. So the first thing it says, the y-intercept of a line is the point on the y-axis where the line crosses it. So it's really super simple. And then number one, it says, what is the y-intercept of this graph over here? Well, it says the line crosses the y-axis at the point 0, 3. So that's what this point is right here. 0, 3. Remember, this is the x value. This is the y value. And for x, we don't move left, right at all. And for y, we go up 3. But no matter what we choose, let's say the line crossed... Oh, I can't move it like that. Let's say the line crosses like this, and it's supposed to hit down there at -3. Well, it's always going to be 0 something. So rather than say... Whoop, dropped my pen. Rather than say 0 every single time, we just put the y value part in. So that's what the next thing is. It says the y-intercept is the y-coordinate of this point. Just the y-coordinate. And I gotta put my marker back. Here we go. So we just say that the y-intercept is 3. So it just becomes a single number. Before we get into an example, I want you to see something. So here's y equals mx plus b, and I made it nice and fancy because it's super important, and it's something we're going to use for so much of the rest of the year. It is the main form, the main for us form of a line. It's called the slope-intercept form. So slope-intercept form. And it says that because the m and the b are a slope and y-intercept. So if you remember from last video, we said m is one of the ways you can write slope. That's because it's m in the formula y equals mx plus b, and b is the y-intercept. Oop, can't spell. And then in the past we've had kids look up why the letter m is used for is used for slope, and we came up with a few things. None of them are guaranteed this is the reason, but some of the earlier words that might have been used for slope, like mountain in French, or to climb is monter, something like that. There was another one, I can't remember. If you want to look it up and bring in some helpful info to us. I think it has something to do with how the word was used long ago. And I can't remember if we looked up why b is used. We certainly can't use y. Y was already used for a coordinate. Okay, so now that we know that, we're going to be dealing with equations in this form. Normally, m and b are just going to be numbers. And we'll work with equations that aren't in that form to get them into that form. But let's jump into an example now. In the first example, it says graph the following. Y equals 2x plus 1. Before we just dive right into the graphing, which is something we'll actually be able to do soon, we'll just be able to graph it right away. We're going to do this a little more methodically so you understand why it all works the way it does. So we're going to pick random x's and see what the y that goes with it is using the equation y equals 2x plus 1. So you might pick something really easy like 0. So I want to know what y is if x equals 0. Well, this equation tells me. It says y equals 2 times 0 plus 1 now. Well, 2 times 0 is 0, plus 1 is just 1. So I know that there is a point on the line at 0, 1. Alright, then I pick another one, maybe a little further away, maybe 5. Okay, now I just say y equals, instead of 2 times 0, it's 2 times 5, because I'm replacing x with different x values. 2 times 5 is 10, plus 1 is 11. And this one barely will fit. Let's see. If I move over to the right 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This only goes up to 10, but I can just kind of make a new spot right there. So maybe I don't want to go, seems like the higher I go with x's, the higher it goes with y's. So I don't want to go past that. Maybe I want to do a negative now. How about negative 2? So I do y equals 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. So I know if I go left 2, I have to go down 3. But I think that's enough. You really only need 2 points to make a line. At this point, you want to get your ruler out, try to connect all 3 points. Should look something like this. You label that line y equals 2x plus 1. We always label it. When we get into another unit down the road, systems, you'll have 2 lines on there, and it'll be really important that you label the lines. And then at the bottom it says, hey, what's the y-intercept? What's the slope? Well, if I look at my picture, remember from the beginning that pulsing red spot? Well, that's right here. That's where it crosses the y-axis this time. And that is at 1. It goes just up 1. And my slope, this is something from last time. I want to go, let's do these points that are pretty close together, right here. That is a rise of 1, 2, 3, 4, and a run of 2. Well, 4 over 2, rise over run, is the same as 2, so my slope is 2. Now, if you notice, this 1 and 2, we knew that without doing any work, because they are up here and here. So there we go. We didn't need to do all that work, although it was nice and helpful to know why the coordinates appear the way they do. Now we can just try another one without doing any of this. So let's try that. Here's another one. This one, it's y equals 1/2 x plus 1. So again, I'm going to skip all of this. And there you go. Nice announcement. That's Miss O, by the way. I don't know if you can actually hear that. She's always interrupting me. Alright, what is the y-intercept? Well, if I look back at the last one, I'm going to keep flipping back and forth here. The y-intercept was in that spot, which is exactly what the equation told us where it would be. It told us it would be at that spot. So I go back to this new one, 1. What is the y-intercept? 1. What is the slope? Well, let's go back. Slope was in this spot, which is exactly what the equation told us. It would be in that spot. So here we go. Slope is 1/2. That's all I need to know to make this line. So we have this little saying that you begin with b, because y-intercept is also known as b. Slope is m. So we start here. It's like a maze, right? Start here. Oops, not here like I hear you. Start here. We're going to start at 1. I'll put a little dot there. It's kind of like I'm pinning my line. And now we're going to know what angle it's at. So we use that term, rise over run, to get this motion down, to find my new points. So we say rise 1, run 2. I'm going to make a little note. So rise is up if it's positive, down if it's negative. Run is always to the right. There are special circumstances where we go left, but only if we run out of room going to the right. So you rise if it's positive, or excuse me, rise up if it's positive, negative if it's, or down if it's negative. I'll get it out. And then run always to the right. So here we go, up 1, right 2, up 1, right 2. You can make as many points as you want. You only need a few. If I wanted to go left, this is what I'm talking about. You don't need to. You can just make the line from this point. But if I wanted to go left, I go back to my first one, this one here, and I go down 1, left 2. So I'm just reversing both of the numbers. The first few times you do that, make sure that you're staying in line and that your line doesn't get kinked when you do that. Oops. My microphone hit the board. So there it is. There's the line 1/2 x plus 1. And I'm going to label it as such. And just to prove we did it right, I'm going to take one of these random points way over here. Let's say this one here, which is the point, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And I want to see, let me erase some of the scribble I made. I want to see if I really did it right. If I plug in 8, will I get 5 over here? So you do 1/2, or excuse me, y equals 1/2 times 8 plus 1. Well, 1/2 times 8 is the same as saying half of 8, which is 4, plus 1 is 5. That's what I wanted. So now we can do it without all of this math. We can just know that this is M and this is B and know how to plot that. Alright, so this one challenges us to think backwards. They give us a bunch of x's and y's in pairs, and they want us to come up with the equation. So we're going to say y equals something. Okay, so let's plot these points that they gave us. -1, 9 is right here. 0, 6 would be right here. 1, 3, these go in a pattern. And 2, something. You can probably imagine what it might be now. But if I were to continue this line, especially if I had a ruler, this would be much nicer. So I'm going to be way off, I know it. I think it was supposed to hit right there. Then I can see that my next one would have been 2, 0. And also, since it was in a pattern, this keeps going down 3 every time. So if I went down 3 again, I'd be at 0. Okay, so but we still need the y-intercept and the slope in order to get our equation. Well, the y-intercept, again, remember that pulsating red dot would have been right there. And that is up 1, 2, 3, 4, 5, 6. So I know my y-intercept is 6. And my slope, now before I even count, I know that this slope is negative because it goes downhill. So I'm just going to put a negative right in there. And I'm going to say a rise of 3 and a run of 1. And that happens every time. Rise 3, run 1. Rise 3, run 1. So that's rise on top, run on the bottom. So just put it together up here. Y equals -3. You can write it over 1 if you want, but I'm not going to. X plus 6. Remember, that's y equals mx plus b. So there you have it. We can go the other way too. We can just have a bunch of points and get the equation from that. Alright, we're going to do one last thing here. We're going to tickle the brain a little more, and we're not going to graph anything. We're just going to see if we can take these little table of points, table of values, and come up with the equation just straight from that. So just a little, we're not going to actually graph it, but you can imagine these points, -3, -21 would be like way down here on the graph. 1044 would be like way up here. 2, 4, that one's easier. So I can see that my line kind of will do this. I know it's a positive slope. That helps me with that part of it. Just doing a teeny weeny sketch there. But I still need, oh, I'm going to write this down here. M, B. I need those two things. Well, I know that M, or slope, is rise over run. So I bet I could use that slope formula that we had a couple classes ago, or last class actually. Slope formula where I take just 2 points and I figure out the difference between them. I'm going to take the non-negative ones. I'm going to take these two right here. I'm going to call this x1, y1. I'm going to call this x2, y2. And then the formula was y2 minus y1 over x2 minus x1. Supposed to be a 2. So that means that's, whoops, random keyboard. I'm going to say 4 minus 44. Probably could have flipped this and not got negatives, but that's okay. 2 minus 10. That's negative 40 over negative 8, which is a positive 5. So there you go. I have my slope already. It's 5. Now B is a little trickier. There's not a point on there that gives us the y-intercept automatically. And if I were to graph it, I could see that it's somewhere there, but since I didn't make a scale, it's not very accurate at all. I know it's probably negative something, but that's not enough to be correct. So instead, and let me get rid of this. This is kind of getting into my way. Take it all apart here. Give myself some room. Instead, I'm going to take my equation, y equals mx plus b. And I'm going to say, well, I want this. This is what I want. What else do I know? Well, I know m is 5. And x and y, x and y. Well, here's an x and a y, right? And these are examples of x's and y's that I could use. So I can use any one of these, and why not this one that's super duper simple, 2 and 4. And I'm going to replace 4 with y, or y with 4, and x with 2. So what I did was I took something I knew, m, in a pair of, Miss O again, 4 and 2, which I knew as my x and y, and I could have used anything. I could have used 10 and 44, I could have used negative 3 and negative 21, or some other point that I knew somehow. But I knew 2 and 4, and they're simple numbers. So I'm going to say 4 equals 5 times 2 is just 10 plus b, and then just as a one-step algebra problem. Minus 10, negative 6 equals b. So I know b, I know m. As soon as I know both m and b, I can make my equation. So my equation is y equals, remember I want this, y equals mx plus b. So y equals 5x minus 6. So you could say plus negative 6 is fine too. And there you have it. Now that last one was a little more advanced, but all the problems that came before that you should be able to do, and we're going to practice a lot in class, and we'll even do a little bit of this in class too. Alright, good luck, and we'll see you tomorrow.